So thank you very much. So hello again. The idea of the landscape of synthetic data. So I have worked tremendously with synthetic data, with inspection planning, with virtual design of the inspection systems, visual inspection systems. And the question was always, okay, what is there? The topic has been hot for the past 4 to 5 years. It has been like steadily rising. It is not completely new. It's been there before, but with the rise of AI, with the rise of processing power and so on, it is back. Now, of course, it's the AI that is usually the main driver of things. And the thing with the AI in the industry sense is, the first thing is, it will solve everything. AI is here for us. And then the next step was like, oh, but we cannot really trust it. Do we know how does it work? It's a black box. You know, people are not really happy to use it. And then when we managed to convince them that it's fine, it's not going to do anything to you, and they were like, but we don't have the data actually needed to train it. I mean, it's nice to train the AI for everyday situations where you get abundance of data, too loud. But the moment that you step into the industry, the data becomes extremely restrictive. Now, this was the idea. With AI project, it is very simple. You have the data, you do the training, you get the results. And many of us working on projects promoting AI to industries, basically this is how we promote it, because this is the ideal idea. What comes out in the projects often is that this expectation turns into this. So the pipeline is much longer. And as you can see, most of it's data. Either you have the data, but you have to label it. Or you don't have the data, so you have to acquire it and then label it. And then how do you label it? Do you trust people who labeled it? Is it correct? Is it imprecise? Is it pixel-wise? Is it image? How long does it take? Who is going to do it? The person on the line doesn't really want to do it because it's not their job, and so on and so on and so on and so on. And eventually you come to the training. And you're like, OK, I have the data. I have my little data set of 300 images. I'm so proud. I'm so happy. And then you start training, and you understand, I need more data. Now, it is because of that whole pipeline and those red parts of the data problems why the synthetic images are here. The data challenges, in general, it's about 3 things. The accessibility. Can we actually get the data? The quality. Once that we have the data, how good is it? And of course, consistency. Because let's have a typical production line. It's running. You have a supplier of a certain material that is currently used for producing this product. And you have set up your imaging system. You're acquiring the images. And you have a snapshot of, if it's a fast production, 1 week. If it's a slow production, maybe a couple of months even. And within this snapshot, you will only get the most frequent defects, and probably of only one kind of material. But what happens if the material supplier changes, which happens, and the product changes completely, and suddenly your solution doesn't work anymore? So the question of the data is not only if we have it, rather that what we have, is this good enough? This is why we have the synthetic data, and everybody's talking about it, at least in my circles, but I can admit I'm probably in a bubble. But given by the amount of people here, you have heard about synthetic data. Who has heard about synthetic data? Hands up. Cool. Who has heard about it before this talk? Awesome. Who has used it? OK, promising. But the whole point is like, you get probably bombarded with different kinds of input from different sides. AI can solve everything, so that means AI can solve the data problem. Potentially. Or you get the information, no, not that. Just rule-based, just computer graphics, we want to know what's happening. Maybe. And you, as the final user, you have to decide, OK, which way am I going? Which flyer am I going to believe? Which group is the loudest when talking about how awesome and efficient their solution is? The point of this talk today was, I will show you what my group is doing, of course. But the point was to give you kind of an overview of what is happening. And I will try to pack it in within this probably like 10 more minutes. So the first thing is, what is the rules-based synthetic data? Rule-based synthetic data assumes that you have computer graphics pipeline that is based on a set of well-defined rules and assumptions that are used to generate the synthetic data. The images are realistic, but you have a full control over the whole pipeline. And then you have the generative AI. That means that you have a model in the background that has been trained on a set of real occurrences and is being used to generate new data in variation that you want to be able to train further AI. Sounds great. What usually is the question is, does this really work? And okay, we had the AI hype. Is this the next hype? Is synthetic data the next hype? Well, I've been in this domain for the past 9 years, and I can guarantee you this is not a hype. And the research that steadily grows and goes into different domains and challenges of the industry and assesses how can it be used and where it can help consistently shows that it is helpful. It is not without the flaws and is not without some different challenges, but so is every application. But definitely, it is not just a hype, and it's most definitely something to be used. Can someone take a picture? The crowd is awesome. Like, there is a huge crowd here. It's great. And this is something that people, you have a person selling you the synthetic data, and the other person's like, yeah, sounds good, sounds good. But I mean, there's this elephant in the room they did never ask, like, can I trust your data? Ask that. Always ask that. So, okay. When you are faced with synthetic data, what do you do? There are so many questions. So it's like, okay, which one do I take? Rule-based, generative AI. What about the domain focus? What is domain focus? What about the domain gap? What about the open source solutions? Can I use something for free? Because we all know, okay, that would be great if I can just, grab something off of internet, try it a little bit. Okay, there are so many new companies all of a sudden. Which one do I take? Which question do I ask? What about the freeware? Maybe there are some very strong companies that are offering some freeware. What do I do? I will give you just a brief overview, but let's start with this. Rule-based or generative AI and the domain focus. Okay, is this a bicycle? Hands up. Okay, there are some people who are not sure if this is a bicycle. Good. Is this a bicycle that you would sit on and drive? Assuming that you can drive a bicycle, come on. Yeah. Okay, do you think this bicycle is safe? Yeah? Yeah? Okay, those who don't think, care to say why? Any takers?
Just look at the front wheel. There's something under the brakes which I would not trust sitting on.
Good point, but unfortunately that is just a reflection. Any other takers? Chain. Nice. How many people do we have here? I would say 50, 60? Are we going towards 100? I don't know. I'm bad at crowd counting. I'll leave it to AI. Exactly. This thing is missing. Has this been generated by a human or an AI? Who is for human? No takers? Who is for AI? So this has nothing to do with AI. This is just fact on people. The guy asked the people to draw a bicycle from their mind, how they remind it. Let me tell you, some of those people were actually professional cyclists. These are their drawings. And this is what the guy did. He did the 3D models based on their drawings. Now, I would say that every one of you has seen a bicycle. It took in the whole of about 60 people looking at this right now, it took quite a bit of time to figure out that there is a very important part of it missing. And this is the problem that we have similar with the generative data. It's about the context, it's about the focus. You need to know what you're looking at. And when we are talking about the industrial data, let's say you have the generative model that generates your data. How do you know that it's correct? You need to look at it. And if we cannot see if the bicycle is correct, how do we make sure that actually these images, so this up there is an actual milled surface. This is what the generative model generated when asked, create me some variation. It's about the context. What the model has been trained on. Does the model know how to generalize? How does it label the images? It's very difficult to create labels with generative models. Always ask how this was done. And then is the question of scalability. Okay, you want to scale to different domains. You want to scale to different surfaces, different materials, different defects. How do you do it with the generative AI? And then just another thing is, when you look at this video, it looks nice. But if you look really close, so this is generated by Sora by OpenAI. You notice all of a sudden that those legs are kind of floating like tentacles, and those tentacles have little things on the top that it's not supposed to, and at some point there is an escalator of little things. It's not supposed to be there. The generative AI has no idea about the physics, the underlying physics. And if you want to use synthetic data that is reliable, you want to have this. You want to have this control. So in the rule-based simulation, you have the context, you have the scale, you have the realism. This is how we do it in my group. We have a rule, we have a parameterization point saying, okay, what is it that we're parameterizing? Is it the defect? Is it the surface? Is it the texture? And then we develop a mathematical model of it. And this is what we use for variation control. So we know exactly what is happening and how scalable it is. This is the framework. So you can set up your cameras, you can simulate the lens, the camera, the position. You can set up defects. You can say, okay, what is the variation? What are the parameters? And you go further to simulate this. You get pixel-precise labels, and you know exactly what is in the picture and what should it be. And then the question is, how real is your data? It is as real as you find it to be real, because the realism doesn't have a real measure. And I am willing to argue with you on this, just not right now because I don't have the time, but afterwards, please do. The problem of the realism measure is it's still on the eye of the beholder. For us, this is real. The question is if it is real for the network. This is why we have defined two types of realism. A priori quality, a posteriori. A priori basically says, is the context with the rules, how it has been designed, valid? And a posteriori says, okay, is the network that is actually trained on these images correct? So all of these are real use cases, and all of these have been simulated with our models. Then you can use another thing that is called domain randomization. That means that you use the control and the variance to exceed. You have the realistic images, but then you exceed the features to show something that is physically possible but very unlikely. This helps the network to learn more. And then finally, what to use. This is just a small overview with the perspective on industry, really strong industrial option. And if anyone, there is a lot of new companies spiking up, so please ping me if you know some other companies that I did not involve here. It's not on purpose. The point is, focus is on industry, on production. So you have the dataset generators, you have the rendering engines, you have NVIDIA Omniverse that is very popular right now, and you have the whole number of proprietary solutions. So the question is what you want. Do you want to implement it yourself? You can use the rendering engines, you can use the dataset generators, you can use NVIDIA, you can use freeware rendering engines. But this will cost you time and resources, and you will have to have an expert doing this. OK, so you say, fine, let's focus that I don't actually spend too much time. You still have Blender, that is cool. But you are shifting about the question is, what is it that you want? Do you want scene understanding? There is a number of options. And then scene and understanding, more or less, every company producing industrial synthetic data can produce you good data for scene understanding. The question is of the context. What is the context? It's the world surroundings. What is the scale? The scale is the geometry of the object. And what is the realism? Well, the geometry has to be right, the world has to be right, but the very fine details, it probably won't matter. The network will extrapolate anyway. And then we are coming to the surface inspection. There, the context is actually the acquisition setup. What do I expect on the surface? How will the defects be? What is the level of realism? How are the defects looking like? Does this make sense? Is it appearing where it is supposed to appear? And with this, again, I'm happy to say, just hit me up. My group is joining together with the startup Medapsi that won the startup of the day yesterday. So we will also be there on the booth because we are bringing the rule-based approach more to the industry. And then one last slide. That was that slide? OK. One last slide. Take a picture. When you're talking to a company or anyone doing synthetic data, these are the good things to ask. if you're using synthetic data, these are good things to do. They're general guidelines. It is nothing written in stone, but it has shown to be useful. So use it, and all of your experiences, please do contact me. Here's my contact data. Please do contact me. Tell me what's your experience. Tell me about your use case. Tell me where it hurts and where it doesn't. And yeah, I'd love to take it from there. Thank you.